Hey everyone, today we're going to take our equivalent ratios that we've been learning about and graph them. You're going to be able to set up a table and then use that table to create ordered pairs and then graph them. So let's get started. A car travels at a rate of 50 miles per hour. Use equivalent ratios to graph the distance the car travels over time. Graph time on the x-axis and distance on the y-axis. So if this says 50 miles per hour, that's a unit rate, isn't it? And this table already has 1 hour right here. We know that in 1 hour, they'll have gone 50 miles per hour. Now to continue and finish this table, all we have to do is times the distance in the hour by the same number, and we'll create equivalent ratios. So we can see that we have 2 hours here. So that means we'll need a times by 2, right? So 100 or 50 times 2 is 100. And oh, that didn't go well, did it? There we go. Now we have 150 here. How can I go from 50 to 150? Times by 3. So let's times by 3 right here, and we'll get 3. Then we can look and see that we have 200, which would be times by 4. And then there's a times by 5. 1 times 5 is 5. So let's do the same thing up on top. 50 times 5 is 250. And you might be like, well, Mrs. Matson, why don't you just count by ones and count by 50s? And the reason, you could definitely, but sometimes there'll be a table, and instead of counting with equal intervals, 1, 2, 3, 4, 5, 6, sometimes they'll put like a 10 here. And if I were just to put 300 right here, that would be unproportionate, wouldn't it? So be careful, be on the lookout for that. We know that it's 50 miles per hour, right? So if we want to go from 1 hour to 10 hours, we'll times by 10, which means we need to times the top by 10, giving us 500 miles in 10 hours. Okay, so now that you know how to set up the table, we can now create some ordered pairs to use for a graph. It's set up here to graph time on the x-axis, which means the time needs to be our x coordinate, needs to be the number. It needs to be the number that we go to first. So with this right here, we are going to say that the time is 1 and the y coordinate is 50. For the next one, time is 2 hours and we have 100 hours right there. 3 hours or 100 miles, 150 miles. I didn't leave you much room, did I? Do you see what's going on here? The time becomes the x-axis, the x coordinate, and the distance becomes the y coordinate. So the way we would graph this first one by going over 1 and up 50, which they have already done for us. The second one would be over 2, up 100, over 2, up 100, over 3, up 150. Starting to see a pattern here, right? And we have, the very last thing we'll do is we're going to connect these dots. And we're also going to have a little arrow at the end. Why the arrow? Well, because the car doesn't necessarily stop after 5 hours, right? The car could continue going and continue gaining 50 miles every hour. So that's what the arrow shows us. Hey, this could continue on. All right, there you go. We just took a ratio, created a table, and then used that table to put it into a graph. Kind of fun, huh? Well, let's do another problem. During a heavy rainstorm, the waters of the Blue River rose at a steady rate for 8 hours. The graph shows the river's increase in height over time. Use the graph to complete the table of equivalent ratios. How many inches did the river rise in 8 hours? So we have that. It looks like after 1 hour, it rose 3 inches. And that is where they got this from. If we keep going, and 2 hours, it rose 6 inches. In 4 hours, it rose 12 inches. In 6 hours, it had risen 18 inches from there. And 8 hours was 24 inches. So I kind of worked backwards. They gave me the graph, and I created a table out of it. So after 8 hours, the question was, how many inches did the river rise in 8 hours? The river rose 24 inches in 8 hours. Have you noticed with those first two lines, the graphs that we've done, that both of them were a straight line? Did you notice that? Well, that was not coincidence. Anytime you're graphing equivalent ratios, they always form a straight line. So if you're ever graphing equivalent ratios and your line kind of goes like this, then you've done something funky in creating your equivalent ratios right here. So go over all of those again and find your mistake, because it will always form a straight line if you're dealing with equivalent ratios. All right, a couple more questions about this river. What does 4:2 represent? When I'm here at 412, what does that actually mean in this like blue river heavy rainstorm situation? Well, if we look at it, the 4 is dealing with time. The 12 is dealing with the increase in height of the river. So it represents the fact that in 4 hours, the Blue River rose 12 inches, right? So yes, it's just a dot, but that dot represents something, and you can figure out what that is by looking at your labels here. And what if it continued? What if it rained for an entire 12 hours, a steady drizzle? How high will the river have risen then? Well, it's hard because over here it doesn't go up to 12, does it? But I bet we could figure out if we just went one more on 12. Looking at the unit rate will definitely help us. It's a 3-to-1 unit rate. So if I want to go from 1 hour to 12 hours, I could just times by 12, couldn't I? So if I went 12 hours longer, then I'm going to get 12 times the amount of rain. 3 times 12 is 36. So if it continued, I would put the 12 all the way up. If this kept going to a 36, it would go at exactly that point. And my line would continue, wouldn't it? What about a redwood tree? Did you know that there has been redwood trees that grow at a rate of 4 feet per year? I know a lot of people that aren't even 4 feet after like 10 years. And this is just in 1 year. So we're going to create a table and graph the tree's growth over the 5 years. So now we're going to create our own table. I am really simple with my tables. I just like to go like this. Isn't that a cool table? And I started off by, it looks like they want time for the x-axis. And so I'm going to put time here on the bottom and height here at the top. So 4 feet in 1 hour, 1 year. So that means in 2 years, it would be 8 feet tall. Wow. In 3 years, I'm going to add another 4 feet, correct? So that would be 12. 4 years, add another 12, that would be 16. And 5 years, that would be another 4 inches or 4 feet, which would be 20 feet tall. That's like 2 basketball hoops on top of each other. Pretty impressive. So now to graph it, I am going to use these numbers down here for my x-axis. I'll just go 1, 2, 3, 4, 5. I could keep going on, but didn't ask for that. And for my y-axis, I'm going to use the height. So I'm going to count by 4s this time. 4, 8, 12, 16, 20. There's my 1, 4, my 2, 8, 3, 12, 4, 16, 5, 20. And I'm going to continue. I'm going to draw my line. I'm even kind of going to have a point at 0, 0, right? Because after 0 hours, 0 years, am I ever going to get that right? After 0 years, it will have grown 0 feet. So I'm even okay starting right here at the origin at 0, 0. Okay, so the question I want to ask now is, what does this 1, 4 represent? Well, it represents a unit rate for 1, right? But it also represents that after 1 year, the tree grew how high? The tree grew 4 feet. Wow, that's so cool. And if the tree continues to grow at the same rate, how tall will it be after 10 years? Well, that unit rate is 4 to 1, right? So that means it needs to be 40 to 10. I need to times both of them by 10. We'll have grown 40 feet tall. I don't know how tall they actually grow, but that's pretty tall. Cool. So sometimes, possibly during the test, you will see a question like this. Meg's job pays her at a rate of $16 per hour. Which is an equivalent ratio? And the way I would solve this is I would set myself up a table. I would just do kind of a quick thing like this, and I would continue on until I saw which one of these showed up. So after 2 hours, it'd be 32. 3 would be 16 times 3, which is 48. Ooh, look at that. I think I found it. 48 hours, $48 in 3 hours. It's definitely not this one, right? That would, for after 4 hours, it's got to be more than 48, huh? So, and definitely not after 16 hours. That definitely doesn't make sense. You'd only make $32 in 16 hours. That would be like $2 an hour instead of $16 an hour. So that is the equivalent ratio. I'm curious about this one. How come this one doesn't work though? Let's figure it out. Oh, it's $84, not $96. Okay, so the answer is definitely C. Now, a word of caution. Or now that you're like, have done this well enough, can you figure out the mistake here? If I say the ratio of teachers to students is 1 to 5, what's wrong with me graphing that right there? It said the ratio is 1 to 5. The ratio of teachers to students is 1 to 5. Do you see what the mistake is? Here's students, here's teachers. Looks like there is 1 student for every 5 teachers. Is that the way it works? No, it should be the opposite. It should be for every 5 students, there is 1 teacher. So the graph should be right there, which means for every 10 students, there are 2 teachers, right? So this is going to be a very, very, very long, skinny line, but it's still going to be a straight line. Okay, now let's see how well you do. The graph shows the distance that a plane flying at a steady rate travels over time. Use equivalent ratios to find how far the plane travels in 13 minutes. The graph only goes to 6 minutes, so what will it be? Well, if I do my table, I've got time, I've got minutes per mile, and it looks like after 1 minute it's 7. So guess what I could even do? I'm just going to go straight to 13 minutes. I can see that I need to times by 13, times by 13. 7 times 13 is 7, 8, 9, 91 miles in 13 minutes. Last one for you. Emilio types at a rate of 84 words per minute. That's pretty good. Good job, Emilio. He claims that he can type a 500-word essay in 5 minutes. Is Emilio's claim sense or nonsense? Use a graph to help explain your answer. So if he can go 84 words in 1 minute, that's words per minute. Can he do 500 words in 5 minutes? Well, I know that in 2 minutes, he could do 168. Ooh, I'm thinking probably not, right? Add another 84 for the next minute. Yeah, I don't think he's gonna make it. That'll be 252. Okay, I could even just jump straight to 5. And times by 5 times by 5, huh? Do 84 times 5, which would be 40. Yeah, he is 80 words short. And I could graph that here. I could go 1, 2, 3, 4, 5 minutes. And I could count by 84s. Okay, I could also count by like 50s. 50, 100, 150, 200. As long as my intervals are the same between every line, I could technically count by whatever I wanted. All right, so 84 to 1, 168 to 2, 252 for 3, 420, 4, 5, which is right about there. We've got ourselves a straight line, but he is talking nonsense. He does not type 100 words per minute. He types 84 words per minute. Okay, my friends, it is awesome having you do this with me. And this is kind of a fun drawing lesson. Have fun with it. See you later.